Welcome to the metrics track. I'm really excited to be here. Are you guys excited? Yeah. All right. So my name is Dieter, and I am from Belgium, the country known for its chocolates, its beer, and having no government for almost 2 years, a few years ago. I did come to New York City 2 years ago, not because of the political problems, but to work at Vimeo. Vimeo is a video sharing website. And so what I do for Vimeo, I started out with clusters to handle our user uploads, their video uploads, transcoding, and storage of our videos. And then another thing, as a consequence of all that work, is I needed a lot of good telemetry, time series metrics, monitoring, alerting, and stuff like that. So I've started to focus more and more on the latter. And one thing where those two come together really nicely is whenever you upload a video to Vimeo, in the backend, we actually have an algorithm running that runs through all our time series metrics that describe the performance of our data centers, transcode wait times, storage performance, stuff like that. And we actually have an algorithm running that weighs out those performance metrics and makes an intelligent decision based on that and how much it costs to operate each data center, and routes your upload to the most fitting data center that's going to give you the best performance, traded off to the cost of it. And so when working on all these things with metrics, I've noticed a lot of problems that I encountered and that some of my colleagues encounter. And so Metrics 2.0 is a way for me to deal with all those problems. So we're going to go over that, and we're also going to talk about a lot of implementations, a lot of uses for those, and some future ideas. My experience is mostly with graphite, so that shows maybe, but I've tried to keep it as general as possible. So let's make sure we talk about the same terminology. Most people seem to agree that a data point is just a timestamp and a value. You put those in sequence, and you have a time series, and a metric is actually just an identifier that points to that time series of metrics. And it could be a string identifier, or in some systems, it's a string with maybe a few tags, like OpenTSDB. And so the problems that I see with this is, for example, when I want to know how many page requests per second is Vimeo.com doing, or what is the write performance of a given server, I have a really hard time finding those metrics. I have to navigate trees or search, but I don't know which words to use. Or sometimes I have to look in source code or ask people, hey, do you know where this metric is? And then when I find metrics, I have the opposite problem. I don't know exactly what they mean, what the prefix is, what terminology is being used, what unit are they in. Is this some kind of aggregate? Is it an average, or is it something else? And where is this metric coming from? Who generated it? Even worse, some agents like collectd have an option called store rates, for example, that actually changes your data, but this change is not reflected in the actual metric identifier. So if you just know the metric, without looking at the configuration of your agent, you actually still don't know what it means. So metrics have an unclear and inconsistent terminology and format. They're very tightly coupled to where they're coming from, and they lack a lot of information that I need. And of course, the more metrics you have, the more this becomes a problem. I would even say that the complexity of just finding the right metrics to have them in your graph is related to how many source applications do you have that are sending metrics. They all probably have their own conventions. How many people are involved that write code that emits metrics? How many aggregators or services do you have that do some kind of operation on your metrics and reflect this by modifying your keys? And of course, the complexity of your graph itself, how many metrics are on your graph. And specifically in the case of graphite, for example, I also notice limitations with the tree model, because very often I need to bring different metrics from very different areas in the tree together, and they have different prefixes, so they have different sections within the tree, or they're being segregated by different dimensions, so it's not really easy to have them combined. So making graphs and dashboards is such a time sink. And another reason for that is also that I notice you spend so much time defining what goes on the y-axis label, what goes in the title, what goes in the legend, what colors to use. And a lot of this stuff could actually be deduced from the metric itself, like if it describes itself a little bit better, has more information, then we don't need to do all this manually. So that's what Metrics 2.0 is all about. I'll go over the concepts first. So it's all about having self-describing metrics that are standardized and that use orthogonal dimensions for everything that you segregate them by. And I'll make it more practical now. So this is a very traditional metric. It's actually coming from OpenStack Swift, which is something like Amazon S3, but it's an open source project. You can run it yourself. So this is a metric that describes the upper 90th percentile of how long it took for an HTTP GET request that returned a 200 OK from a proxy server running on the specific server. And in 2.0 format, that looks like this. So the aim is to be more self-describing, so you know better what's going on. It uses standards that describe which terminology should you use, what should you put in your keys and your values. Every dimension has a key, and this will become very useful later in the examples, as you'll see, that makes the dimension useful by itself. And the units are mandatory, so you must always know what unit a metric is in. So specifically for units, we basically base ourselves on some existing standards, and then we add units that we need in our field of IT, like bytes, errors, warnings, connections, and so on. And then, of course, you can make compound units, like megabytes a second, errors per day, requests an hour, and so on. Another goal is to be less restrictive on which characters you can use, because, for example, slashes can be very useful in your units, or dots can be very useful in your values. And then another goal is, for example, with Graphite, whenever you want to add a piece of information to a metric to describe it a little bit better, you always change the identity of your time series, so it starts writing in a new time series. But sometimes you don't want it. For example, if you want to track where a metric is coming from, so that if you want to debug cases where something is sending invalid metrics or is just sending way too many metrics, you want to be able to track that. And if the file changes or the line changes, you want to keep tracking it. Or if it's being processed by an agent or an aggregator, if you switch the agent, you're still measuring the same thing. You don't want to get a new series. It's still the same data. So there's also a way to track this metadata and track changes over time. So all this stuff is described on the website, metrics20.org. So the goal is to understand immediately what a metric means, to minimize the time to come up with graphs, alerting, and troubleshooting, and this will become more apparent later, and to be more to have more compatibility amongst your tools and flexibility in choosing which tools you want to use without breaking things. So in terms of implementation, let's first go over how do you actually get this data. And there's two ways. If you already have existing metrics, for example, from Graphite, you can use these Python plugins. They come in a library called Structured Metrics, which is part of Graph Explorer, which I'll go over later. But the point is, it's basically just regular expressions that parse your metrics. And using named groups, you just convert them into the 2.0 format. The other way to do it, if you have the liberty to write the code that actually generates the metrics, from the source, you can have them in the native 2.0 format. And there's still a lot of discussion on what is the best format to do this. Like the first one is just the key value pairs. The second one is a string, but with small annotations, what each dimension is. The third option is maybe just passing on an ID and then having separate metadata or a separate set of the 2.0 format that describes the ID. And so once you can submit in this native format, there's another service that you can use called Carbon Tagger. This one speaks the Graphite Carbon protocol, and basically whenever it sees a metric that is in the 2.0 format, it will maintain all this information in an Elasticsearch database. As your metrics flow in, it automatically updates, so you always have a database that reflects which metrics you have in real time. So schematically, that looks something like this. You have your metrics coming in from your environment. You could go just straight to Graphite and use the structured metrics library with those Python plugins. They write to Elasticsearch. The simple setup like that works. You could make it a little more interesting. If you use a pipeline like Kafka or Rabbit or Carbon Relay NG, then you can hook in Carbon Tagger, which does the which parses your metrics in real time and updates your database in real time. And then as an end user, you will use something like the Graph Explorer dashboard, which I'll go over next, which uses both the Elasticsearch metadata store and the Graphite time series database. Then there's another service that might be useful to you. If you use something like Etsy StatsD, this is very similar, except when it detects that an input metric is in a 2.0 format, it will change the tags accordingly. So when it computes something into a rate per second, it will change the unit tag for you. Or when you send it a whole bunch of timing values and it gives you the summary statistics, it will still do the same thing. But for 2.0 metrics, the way it reflects that is by filling in the stat value that describes which kind of statistic is it. Is it the mean, the upper 90th percentile, and so on. So the goal of this is to make sure that your metric tags are always in sync with the data that they point to. And so the actual uses of all this, there's basically three main categories: graphing and dashboarding, visualization, and alerting. I'll now go over graphing and dashboarding. And I'm going to do this by using the Graph Explorer dashboard, which is an application that is, it's basically Graphite dashboard, but it's specifically written for Metrics 2.0. And so when you start with it, you just have a query field. And in the query field, you can just enter a few words that you know are going to match some of your metrics. And this is the simple way to get started. You just type, for example, proxy server Swift. And then in this case, we do a regular expression on server because we want to restrict it to a few servers. And we say that the unit tag must be in milliseconds, so to get all the timing metrics. And this is going to give us something like this. It's going to collect the metrics and put them into graphs. The one thing you may notice from this is that there's a lot of tags being displayed on the page on various places. And we only show the tag values, but they're color-coded by key. So on the upper right corner over there, you can actually see that the unit tag is in yellow. Target type, which is like gauge or rate, is in green. HTTP code is in pink, and so on. And so what happens is you type the query, it gets the metrics, and then it groups the metrics into graphs automatically. And so you have the section on top that gives you some more information about what's going on. And so the default group by is unit, target type, and server. And this means that all your metrics, if they have the same value of unit, target type, and server, they will go on the same graph. So in this case, we have one graph, which is a gauge in milliseconds, and it's proxy server 1 in the title. And then under that, we will have other graphs for other servers, for example. And what goes in the title and what goes on the y-axis is being automatically filled in based on the unit tag and based on everything that the metrics on the graph have in common with each other. So all the stuff that they have in common goes either on the y-axis or in the title automatically. The stuff that sets them apart from each other, obviously, are those tags that are different from each other. Those go in the legend. So in this case, we see that we have a lot of different stat values. The first one is mean. We have a lot of different HTTP methods. The first one is get. And then there's different Swift types. It has a few types like account, object, and stuff like that. And it's also segregated by HTTP code. So this is not that useful. So what you typically do is once you type in a basic query, you look at the results, and then you narrow it down a little bit. So we can narrow down by just typing upper 90 in addition to the query, or stat equals upper 90 to get the upper 90th percentile. In this case, we're also going to do from to a certain time range and average over 10 minutes just to make the graph a little bit smoother. And this is going to give us a pretty similar result as before, except we're now looking only at upper 90th percentiles. And now there's only 3 dimensions that set the metrics apart from each other. To make this actually more useful, we can do something like this. Let's say we want to compare the put and the get speeds. So we restrict HTTP method to put and get. We say Swift type, only objects, because that's the ones I care about in this case. And then average it across all the different values of HTTP code and server, because in this case, we don't care about them. So if the metrics are identical, except for those 2 tags, average them together, and put it on a stacked graph. So in that case, it looks like this. And basically what it's telling us, it's comparing gets and puts averaged across those other dimensions that we don't care about. So in this case, it's basically showing us that puts take longer than gets, averaged across all those, in this case, 4 unique values of server, for example. Another way to visualize the same information, we still say only puts and gets, but now we're going to group by unit and target type, not by server anymore. So different values of server go on the same graph. And we say average by all those other dimensions that we don't care about anymore. So now we get a graph that lists the 4 servers, but across those different values of those other tags that we don't care about anymore, just average over those. And now this visualization tells us one of our servers is actually slower than the other ones. I'm going to switch to another example. I know that we have transcode jobs running. So I know if I just type transcode and then unit equals jobs per second, which is a standardized tag, I know I can query for them. So by default, it just puts them all on this one graph, which is not that very useful. But the point to notice is that there's 2 tags that separate them all from each other, the job state and the Amazon zone. So what we can do, for example, is say, OK, let's sum them by zone. And in buckets, make me a bucket of all the ones matching EU-West together, all the ones matching US East together, and so on. And group it by state, which is the job state in this case. So what happens is now we have a graph for all the active jobs comparing the Amazon regions, which are the sums of all the matching Amazon zones. And then under that, we will have a graph for the other for the other states. So now we can compare basically how many jobs in active state those different Amazon regions have running. But we can visualize this entirely differently if we just say group by zone. So now in this case, we actually have a graph comparing per Amazon region, which is still the sum of those matching zones, how many jobs do we have are starting, how many are failed, how many are active, and so on. And then there's a third example that I wanted to show is, let's say we want to query for network in megabits a second for servers matching a certain regular expression and sum it by server. So now we see a graph where different values of servers are aggregated, but we basically see for every interface and in and out, we see the sum of the traffic from our different servers. But in the dashboard, if you would click on the legend, you can actually see which metrics contribute to what is being rendered. And in this case, if you actually look closely, you would see that unit is in bytes per second, even though we queried for megabits a second. And Graph Explorer, what it actually does is it knows that the 2 are compatible, and it knows how to convert between them, so it can still satisfy our information need and display it in megabits a second, even though the original metric is in bytes per second. We can take this a little bit further. Still the same metrics that are in bytes per second, if we query for them in terabytes, not per any time, it is actually automatically going to integrate our data for us. So now we can actually see the cumulative sum over time of the same data, but automatically integrated because that's the unit that we asked for. The other way around, if you have a metric that says unit is in bytes, like for example disk space, we can query for it in, for example, gigabytes per day to see the rate of change. And I do this sometimes. It's automatically going to derive the data for me. And in this particular example, I have graphs for every mount point comparing the rate of change per different server. And at this point, I should also mention that I believe in equal rights, and that also counts for your tag keys and values. So you don't have to use the standardized tag keys and values if you don't want to. Everyone has a different need. So there's currently no real checking. So you just use whatever tags you want to. But the goal is that based on what people are using in the real world for their tags, those could eventually be integrated into the spec. So in particular, if you have a unit tag called anything, you can query for anythings per second or mega anythings per day or anything like that. And then another thing I wanted to point out is that I also hate configuring colors on my graphs. So what I do instead is I just type in one place that I want to see idle CPU usage in green, for example, and user space CPU in blue. And wherever I plot that on any graph, it's automatically going to honor those color definitions. So in this case, for example, I have graphs for every server comparing the different CPU states, and it's going to color them the way I asked for. But if I do group by CPU type instead of by server, which gives me graphs comparing idle for all my servers, comparing user space for all my servers, and so on, it knows that it shouldn't use the same colors again, because then the entire graph would be green, and then the one below it would be blue, and so on. So it also knows when not to do it. So the whole idea behind this is I want to minimize as much as I can the time it takes for me to come up with my graphs and my visualizations, if I can just express my need as a query. And I have some future ideas to make this a little bit better. I want to make it a little bit more user-friendly, for example, by automatically suggesting new tags that you could add to your query. Some people also seem to be interested in having the ability to define their own hierarchies, so you could make your own hierarchies. Even though the tag space there's no hierarchy, but you could define your own. And I want to provide some more tag insights in the dashboard that say, okay, here's how many standardized tags you have. These are not standardized. Maybe they should be added to the spec or something like that. And then another thing that I like to think about is there's 3 different cases where you often need to consolidate data points that are in sequence and consolidate them into one. For example, with storage aggregation, if you have short-term high-resolution data and you want to store it in longer-term lower-resolution data, that's when you need to aggregate points together. Or Graphite has some API functions where you say summarize in this time frame. Or another example, the third one, is graph renderers. Sometimes they have more data points than they have pixels, so they also need to consolidate them somehow. And what I see often is that graph renderers will just average your data, which can yield very misleading graphs because you don't see your peaks anymore. You don't see your spikes. Even worse, not only do I see people with broken graphs, they also have broken data in their storage because their aggregation rules are badly configured, or there's a metric that isn't parsed well. And 2.0 also solves this because you can safely assume that every metric is an average, except if it says stat equals upper or lower or mean of whatever summary statistic it is. And based on this, you can know, okay, this is how I should consolidate them together, and you know that your data will be sane. So now I want to go a little bit more into visualizations, and this is actually a logical extension of this, but if your metrics self-describe them the way they do, you could also just plot, for example, the average and then the range around it that are the upper and the lower, for example. Or if you have a histogram over time, this would be metrics that say, for example, okay, this metric is a bin that describes how many values have I seen between 0 and 10, how many values between 10 and 20, how many between 20 and 30, and so on. And at every point in time, you have all these metrics. So you could plot a histogram over time with a heat map, which wouldn't be too much work, because if the metrics describe themselves like this, you could automatically detect it and display it this way. And then the third big case that I'm getting more and more into lately is better alerting. So one thing that Graph Explorer also lets you do is you can put expressions, which could be a Graphite expression or a single metric, or a query, a Graph Explorer query, and set thresholds on that. For example, in this case, I'm asking for all the servers matching a certain regular expression. I want to get everything that has type free in gigabytes, so that's disk space, and for all mount points matching a certain pattern. And it's going to visualize it by a graph per server with the different mount points. And those warning and critical thresholds, it's going to apply it to every single one of the things that is being graphed. So in this way, I can just set a threshold on all my mount points, on all my different servers, with just one rule. And as we've seen before, I can do something like sum by mount point, comma server, which would sum across different mount points and servers, which lets me put alerts on the aggregate free space across my entire storage cluster. And then another thing I like to think about is there's so many applications that have metrics that describe how many errors they've seen, but they don't do it in a standardized way. If they all would adopt a standardized terminology so that you would know in one big overview all the errors you're getting from all your different applications and things that are out there, that would make some things more easy. For example, at a previous company, we had something like this, where we had this dashboard that gave us real-time insights into how many errors we were getting from our different metrics. And so we had a column for every site, which is for every spoken language, we had a different website. And we had a row for every different type of error. So with 2.0, this becomes much easier, because now you could say, for my rows, I want to segregate by this dimension, and for my columns, do it by, for example, language. And so this gives you good real-time insights. And then if something is erroring, you could actually drill down a little deeper and find out more, OK, which tags are actually erroring? And is it, for example, on all servers, or only a specific of them? Or is it on just one? Or is it based on data center? Or is it based on different services? Something like that. And then beyond just metrics that are errors per second, I'm also starting to play a little with anomaly detection. So this is, for example, a graph of requests per second of your web application or something like that. And so I have a rule set on this that detects whenever there's a spike up or down that deviates much more quicker than usual, it will flag an alert for an anomaly. And so if you take all the alerts that you have, your anomalies, your error per second thresholds, anything, and you think about, OK, what if I collect all the tags in my good metrics that are not alerting and all the tags that are alerting, then I know, for example, that the ones in the middle don't really correlate to any specific. They don't really say if it's good or bad, because the same tag occurs in both good and bad. But the metric on the right, service equals MySQL, that is probably an indicator that it's very closely related to what the actual problem is. So this way, you could also do a little bit more insights at a glance of what's going on in your infrastructure in case of problems. And then, so there is already some algorithms that detect anomalies. There is algorithms that know how to cluster similar-looking time series together. But none of this that I've seen actually can leverage metadata for this. So the thing that I would like to approach is an application that could tell you, for example, OK, I have seen that that one specific service on these services within this one data center caused a load spike. And then the result of this is this and this service started having problems in this and this data center on, for example, these servers. So using this metadata, you could get a lot more insights at a glance. And then, so another problem with anomaly detection on time series right now is that some projects just run a bunch of algorithms on all your time series at the same time, but they can't really be aware of what is actually required or what is the expected behavior for this one time series. So if your time series already have all this metadata that 2.0 gives you, you could classify them better. And for example, say, Chrome tabs, we expect them every day they're going to have a spike. It's normal behavior. Or disk space is a sawtooth. Apply a different anomaly detection algorithm on that. Or for your web application and requests per second, it's probably going to be something pretty smooth. So if there's a spike, that would be a problem. So using this metadata, we can apply different algorithms on different time series. And we should get a lot better signal-to-noise ratios and better alerts. And then another thing, this is pretty obvious maybe, but some people are responsible for different services, and not everyone is responsible for the same thing. It would be trivial to say alerts related to this metric from this service routed to this one person or these people. Or if it's coming from this data center, well, then it's not critical versus another one could be critical. I also like to think about how can we do a better job at integrating logs and metrics. And so now in the simple case, this is something we already have. We have all our important events stored in Elasticsearch, and we use the Anthracite application for that. And so another thing that you can do in Graph Explorer is whenever you're plotting a query of your time series metrics, you can also execute a search. So in this case, I'm actually rendering CPU usage on our statsd server, and I'm doing a search for statsd in our events database. So this actually tells me, OK, right at this point, there was an event related to statsd, and I can get a lot more context what's going on my graph. And this is pretty trivial, but what I would like to do next is saying, or just putting extra metadata in our events that specify which service they are, so that automatically, if you're looking at data corresponding to a specific service, we could automatically pull in the right events related to that service. Or if we do a little bit more modeling, and if we know which service is depending on which other, and we look at graphs, then we could automatically pull in events from the services that we depend on, or of services that depend on the service that I'm currently looking at. So this would be a good way to get only the events that are actually relevant to your particular graphing scenario. And then I also like to think about when you're running an anomaly detection algorithm, or when you're creating a graph, it actually doesn't matter. You're expressing a certain thing like we did before with the queries. And it doesn't matter which of your storage systems it comes from. It doesn't even matter if it's coming from time series. It could be from your logs. If your log records use the same tags as your metrics, then you can just execute the query and get the data you need without having to care which log server is it in or which of my time series system is it in. Same thing for alerting. You wouldn't have to worry about that. So in conclusion, I think that if you structure your metrics a little better, and if we do a better job at making them self-describing and using some standardization, we enable a lot of useful things. And I hope that I did a good job at going over them. If you have more ideas about this or concerns or advice, please let me know. I would be very curious to hear your thoughts. It is ready for early adoption. At Vimeo, we're actually already using most of this stuff. And I would like to work with you on advancing telemetry and making it better and using these ideas and seeing as a community how we can do a better job at this. So here's some projects that came up during the presentation. We also have a few more open source projects. Those are there. Might be interesting to you. They're all monitoring related. And there's two Google groups. There's a Metrics 2.0 specific Google group. There's a new one also, IT telemetry, for trying to advance the state of the art of telemetry with anomaly detection and stuff like that. So those are some social, Twitter, email, whatever. If you have more questions, we have a little bit of time for questions right now, but if you want to talk more, I'm also going to be at the LISA Labs. I'm not sure where it is yet, but it's going to be after lunch, 2 to 3:30, I think. So now we have some time for questions. Yeah.
Have you ever heard of Project Kale by the
Kale.
Etsy team?
Yes.
Is there any integration with your tool?
Sorry?
Is there any integration or shared code that you have with that?
Is there any?
Skyline components or any of the event correlation that it does?
I've looked at it. So the question is, have I looked at the Etsy Kale stack, which has a project called Skyline? I've looked at it, but one thing that strikes me a little bit odd is that they try to apply algorithms to all of your data at once, from what I've seen. I still have to play with it more, and actually this is high up on my to-do list, playing with it, but from what I've seen so far is that you just define in a config file which algorithms you want to run, and the project runs that on all your time series, no matter what they are, no matter what their supposed behavior is, no matter what you would classify as an anomaly. And that looks a little weird to me because you don't really do a lot of configuration or customizing. And I would suspect that you would get a very high noise rate and lots of false alerts. I've spoken with a few people who've tried it, and that's what they told me. I would be very interested in hearing more people who have tried it more and seeing what they think. But my idea of it is, and this could be maybe be a feature enhancement of Skyline, but I would try to spend a little bit more time on classifying your data and labeling, this is how it should behave, this is what would be anomalous, and then using more optimized algorithms for that. And I would think that that should give you better results. But I have to play with it more, and I would be happy to talk more about it and see what you had. Sorry, I can't hear you. Yeah.
I thought the part in the beginning about curating metrics and finding standards was pretty interesting. Have you had any luck or success finding a common language across different organizations?
Language, as in the terminology for your tags and
the set of labels, the names for these, how fine a granularity people want to slice them up, or how coarse and so on.
I would say that the spec right now is mostly a reflection of what I've needed so far. I am trying to get more collaboration with other people and getting more input on this. I've spoken to a few people who are in the process of trying to adopt it. So I think this definitely requires more collaboration between people and see what do you need, what do I need, and how can we make this work so that we can come up with a standard that works for as many people as we can. There's a little bit of discussion on the mailing list as well. I mean, the Google group, there's a few people who've commented on that. So I hope to work more with people on that.
Hi.
Hi.
Which algorithms do you use for anomaly detection, especially when you don't know how your time series should look like?
I have not run any algorithm on any series that I don't know what it should do.
No, because you mentioned that you can use some information about your data, like, I don't know, how, like,
yes.
What are the spikes, what is the expectation, and then it's clear what the anomaly is. But otherwise, like in a generic case, like, because I got the impression that you also did some work in that direction.
So what I've been doing so far is making sure I have the correct metadata for my metrics, and then using specific algorithms case by case. And actually, I've only addressed one case so far, so I haven't really done much on this. This is what I'm currently working on. But specifically right now, I've addressed a case where unit is, for example, requests per second. And most of our metrics, well, actually, it's also case by case. So I say, for example, web app requests per second, or logger requests per second. And I know that all of those things should have a fairly smooth seasonality. Maybe Sundays are different. Weeks could also be different. But I focus on the one specific case where those time series exhibit a very sharp spike up or down. I have not gone in the other use cases yet, such as cron tabs or stuff like that. And so what I use specifically for, like the one I showed before, is just, it basically just computes the standard deviation of a moving window, and I've just set thresholds on which deviation do I accept, what do I find acceptable. And if there's a spike, then the standard deviation will increase. And that has been so far a pretty good indicator of what would be anomalous. But I have yet to try all the different cases, and I don't have anything that would like automatically inspect your time series. For now, the way I approach it is always looking at the actual metadata and the tags. All right, looks like we're done here. Thank you very much.